the Aquatic Center for swim practice, getting ready to solve some quadratic equations. We're finally got that quadratic toolbox full enough that we can start solving them. So let's go ahead and get to it. Lesson 3A-7 is going to be over solving quadratics using square roots. Our learning target is that we can solve simple quadratic equations by taking the square root of each side. So we have one vocabulary word here, so let's go ahead and go to your glossary so we can fill that in. A root is the x values where the function has a value of 0. So that's going to be basically the place where it crosses the x-axis. And we're going to look more into that when we graph in 3B. But I just wanted to introduce it because we are going to be throwing this word root around a lot. So basically we're looking for the place where this function crosses the x-axis. Okay? So let's go back and get into the notes. When solving linear equations back in Unit 2, you relied heavily on inverse operations. You were trying to isolate your variable using inverse operations. We're still going to be using some of those same methodologies when we're solving quadratics. So we did cover way back in Unit 1 that the inverse operation of squaring a number, so what I mean by that is the opposite of x squared is taking the square root. Okay, so if you have x squared and you take the square root of it, you get just x. If you have square root of 4, which remember 4 is the same thing as 2 squared, and you take the square root of it, that square root and that exponent of 2 cancel each other out and leave you with just 2. The square root of 4x squared, that's the square root of 2 squared and the square root of x squared. Those square roots and that exponent cancel out to leave you with just 2. That square root and that exponent of 2 leaves you with just x. So since we know that inverse operation, we can solve simple quadratic equations. So when I see x squared equals 49, all I've got to do is take the square root of both sides. Square root of x squared is just x. The square root of 49 is either positive or negative 7. It's important that you know that you're going to have both a positive answer and a negative answer on these, because if you think about it, 7 times 7 is 49, but also negative 7 times negative 7 is equal to 49. So that's why we have 2 roots of each of these. Not every single quadratic equation is going to be a one-step solution. Sometimes we have to work a little bit in order to get that x squared isolated, because you have to wait until you've got that x squared all by itself before you take the square root. So let's go ahead and look at some slightly more complicated examples. I'm going to give you a step-by-step process for how to solve these, and we're going to give you those step-by-step processes for every method we give you for solving quadratic equations. So here, simplify each side by distributing and combining like terms. That's the same thing we do when we first start solving a linear function. Then I'm going to move all my variables to one side of the equation. That is also the same as what we do in linear. Here's where things differ just a tiny bit. In a linear equation, the next thing we would do is isolate your x. In this case, or your variable. In this case, you're isolating that x squared using inverse operations. And then you have to take the step of taking the square root of both sides of the equation. Please remember that there will always be 2 roots. There will be a positive and a negative answer to each of these. Alright, so there is no distribution that needs to happen here. There's no like terms that need to be combined. So step 1 and step 2 are taken care of. Now we have to do step 3, which is get that x squared by itself using inverse operations. Okay, so here's my starting point. I'm going to add 338 to both sides. That leaves me with 2x squared, and over here I'm left with 338. Then I'm going to divide by 2. which leaves me with x squared equals, I want to pull up the calculator, you can just to be sure, 338 divided by 2 is equal to 169. And now that I've got my x squared isolated, now I'm ready to take the square root of both sides. So I take the square root of x squared, take the square root of 169, square root and the square cancel and leave me with just x. And the square root of 169 is plus or minus 13. So that means x could be positive 13 or x could be negative 13. Okay, for our next example, we do have some distribution to do, so we're going to distribute 2 to both of these. So 2 times x squared is 2x squared. 2 times negative 5 is negative 10. And then I've still got negative x squared minus 1 over here. Okay, I don't have any like terms on each side that need to be combined, but I do want to move all my variables to one side. So I'm going to add x squared. Remember, here's my divider. I'm going to add x squared to each side. 2x squared plus x squared is 3x squared minus 10. Over here, all that's left is negative 1. Okay, now I'm ready to start getting that x squared by itself using inverse operations. These steps are going to be very, very similar to solving a linear function. So I'm going to get rid of my constant first, which means add 10 to both sides. That leaves me, I'm going to go up here, that leaves me with 3x squared. Negative 10 plus 10 is 0, so that's gone. And on the other side, negative 1 plus 10 is 9. Now I'm ready to divide to get that x squared by itself. So I'm dividing by 3 on each side, which leaves me with x squared equals 9. Now that my x squared is by itself, I'm ready to take the square root of both sides. So the square root of x squared and the square root of 9. That leaves me with x equals plus or minus 3. Okay, this one is going to look very, very similar. I'm going to go through it a bit quicker for you. So here's my divider. I'm going to subtract 3 from both sides because I always deal with my constant first. That leaves me with 1/2 x squared equals 12 minus 3 is 9. Now I am going to get rid of this fraction. Now, the easiest way to get rid of this fraction is going to be to think of it as I'm dividing by 2. If I multiply by 2, 2 times 1/2 is 1. So that cancels and leaves me with just x squared. Over here, 9 times 2 is 18. When I take the square root of this, what I'm left with here is x. Over here, 18 is not a perfect square, so I'm not going to get a nice pretty plus or minus 13 or plus or minus 3. Instead, the square root of 18 can be simplified, and here's where we go back to some Unit 1 properties. Oh, sorry, I made a mistake there. 9 times 3 is not 18. 9 times 3 would be 27. Here's where I go back to some Unit 1 where we were practicing simplifying radicals. 18 is 9 times 2, and 9 is 3 times 3. So that means I'm pulling a 3 out, and I get x equals, remember it's plus or minus, 3, and then that 2 is left behind. So 3 root 2. Also remember you can put that in your calculator. So that means I've got x is positive 3 times the square root of 2, or x is negative 3 times the square root of 2. Okay, example 5, the last example. In this case, I can't really get my x squared by itself because it's trapped inside of a parentheses. So when you see something like this, what I'm going to do is I'm going to get rid of that pesky exponent by taking the square root right from the start. But again, anything I do to one side, I have to do to the other. That cancels out that exponent and leaves me with just x plus 6. Over here, remember that the square root of 49 is positive or negative 7. So then we have to split and kind of do two problems. On one hand, x plus 6 could be equal to positive 7. On the other hand, x plus 6 could be equal to negative 7. So my other problem becomes x plus 6 is negative 7, because when I take that square root, I have two options. So then
if I subtract 6 from both sides, I meant to do that in blue, but who cares? If I subtract 6 from both sides, I'm left with x equals 1. Over here, when I subtract 6 from both sides, I get x equals negative 13, because negative 7 minus 6 is negative 13. I'm going to really quickly plug these solutions back in to show you why they both work. So if I plug 1 into that original equation, remember my original equation was x plus 6 squared equals 49. Well, if I plug 1 in for that, or substitute 1 in, then I've got 1 plus 6 squared equals 49. 1 plus 6 is 7, and 7 squared does equal 49. So that one works. On the other side, I have x plus 6 squared equals 49. And if I plug this negative 13 in, then, if I plug that negative 13 in, then I'm going to get negative 13 plus 6 squared equals 49. Well, negative 13 plus 6 is negative 7. And negative 7 squared, that would be negative 7 times negative 7, that equals 49 as well. So that one also works. So that's why we have two solutions to this problem. We have x equals 1 or x equals negative 13. All right, there is not an application for this lesson, so go ahead and start doing some practice and let us know when you're ready for a mastery check.